Hi friends, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, we have already completed 5 sessions. If you want previous, click on playlist. You can find out all the previous. Let us start today's session. Let me check up to which we have completed in the previous. So all these questions we have completed. Last is also started, I think. Last is also some questions completed. Yes, this is the first question in this today's session. Students, if you have not subscribed this channel, please click on subscribe button and encourage me with your likes and comments. Thank you guys. First question, area of hysteresis loop represents dash. Area of hysteresis loop. Hysteresis loop represents hysteresis losses only. Here, whenever we are giving the supply, that is AC supply, that is alternating nature, here due to positive off cycle means it is magnetization, and due to this negative it is demagnetization. So if you are providing AC supply, there is a magnetization action and also demagnetization will be happen. So this continuous cycles of magnetization and demagnetization, we are getting the losses. Those losses are nothing but we can say hysteresis losses. Okay. So here we can understand this one by B.TECH car. Here I am going to take magnetizing current and that flux or flux density. Here during the magnetization, as current increases, the flux or flux density will be increases. Okay, flux density is nothing but flux by unit area na. So but whenever in the demagnetizing off cycle, that is negative off cycle, what is happening, it may not comes reverse in the same direction. Instead of this one, it will be like this. Okay, it will be like this, and again it will comes to the 0. That means here what is happening here? Here we are getting the loop. Okay, so this area of the loop is nothing but area of loop represent hysteresis loss. For example, if the curve is linear, there is no loop, then no losses. Okay, then no losses. That means if you want to get linear curve, we have to replace the air core. We have to replace the magnetic core with the air core. That means we don't want to take any iron materials. Instead of that one, we have to directly transfer the flux through the air. Okay, so in that case, we are getting the linear curve. But due to that, we have to give more magnetizing current, power factor is less. Those are consequences are there. Okay, so here we are taking the magnetic core to reduce the reluctance. Okay, so to transfer the more flux through it. So for that purpose, if you are giving AC supply, here you are getting hysteresis loop that represent hysteresis losses. Okay, so here height, this height is determined. Height gives the Vmax, and this width is given by volume of the core. If only one loop is there, one frequency. If you have several frequencies, then several loops will be formed. Okay, coming to the next question, distribution transformers are designed to have maximum efficiency at dash. Maximum efficiency. So we have to design the maximum efficiency at a load in which the transformer has operated more. That means distribution transformers are generally operated 75% of the load, that is 3/4 of the load. So that's why we have to design the maximum efficiency nearly at 3/4 of the load. In case of power transformer, distributed transformer is may not operate as a full load now. So generally it is 3/4 of the load. So we have to design the maximum efficiency to get at that particular load. Power transformer always full load. Okay, so we have to design the maximum efficiency to get at this full load only. Okay, so here power transformers are always fully loaded. So fully loaded means copper losses are more dominated. Copper losses more dominated. So we have to design to get minimum copper losses. Very important question, guys. So the power transformers are designed to get minimum copper losses. Okay, in the same way distribution transformers are 50 to 75% of the load generally. So that's why in this case, if it is a 50 load, 50%, 60%, then iron losses are more dominated. Iron losses more dominated. So design to get minimum iron losses. Okay, very important question. Design to get minimum iron losses. Okay, note on these points. Coming to the next question, power transformers are designed such that maximum sales occurs at dash at full load na near to full load. Answer is option B. The iron losses per unit frequency in a ferromagnetic core when plotted against a frequency is dash. We know the iron losses. For example, let us take the iron losses are nothing but full load copper loss plus iron losses are nothing but hysteresis losses plus eddy current losses. Eddy current losses. Okay. So Pi is equal to hysteresis losses AF BF square whenever the B max is constant. Okay. So here iron loss is per unit frequency. So per unit frequency means per unit frequency. Then here FF cancelled out. Here 1F is cancelled out. Then BF. So A plus BF. Okay, like that is nothing but like A plus BX format. So A is a constant, B is a slope now. So if you draw that curve, iron losses per unit frequency, then a constant A you will get is the constant A. From that you are getting BF, that is directly proportional to frequency. So slope is B. Okay, so here slope is nothing but positive side. So straight line with the positive slope. So the answer is option A. A straight line with a positive slope. So the answer is option A. Okay, all of you clear? So constant is A and slope is B. Very important, guys. Straight line with a positive slope. From the figure, hysteresis and eddy current losses at 100 Hz frequencies are dash. Here they have given a diagram. Pi by F, 0.01 is a constant and 0.001 is the slope. So constant is nothing but A na. Constant is nothing but A. Slope is nothing but B. Okay. So they are asking hysteresis losses. Hysteresis losses proportional to frequency are AF. A is nothing but 0.01 into F is nothing but 100. So that is 1 watt. So 1 watt we have two options are there. Eddy current losses BF square. GB is nothing but 0.001. F square means 100 square. 100 square means 10 power 4. Here 10 power minus 3. 10 power 1. So that is 10 watts. So the answer is option A. So the answer is option. Okay, all of you clear? Very simple question. If we know this is the A is a constant, B is the slope, so we can easily get the idea. Okay. So all of you, let us take a small table, and here I think all of you know about this, but still I want to give the condition is nothing but whenever the B max is constant, I mean V by F is constant. Whenever the V by F is constant, that is B max is constant, in that case, what about the hysteresis losses? What about the eddy current losses? We know hysteresis losses formula. Zeta into B max power X F into value. Eddy current losses, eddy D square, and all the terms are in square terms. B max square, F square. Here thickness of lamination will come T square. Okay. T square. So if the V by F is equal to constant, that means B max is constant. Whenever the B max is constant, WH is proportional to frequency. So that is WH is equal to AF. This is the formula for WH is equal to AF I have used it here. Eddy current losses, as B max is constant, WE is proportional to F square, that is BF square. Already we have taken A as constant, now we have taken B. So total iron losses will be hysteresis plus eddy current losses, that is AF plus BF square. Okay, we can represent these losses or power in terms of WRP. Okay, WRP, both are same, don't confuse. Okay, in the same way, if the B max is not constant, in this case the V max is not constant, so B max is nothing but V by F now, V power 1 V power X by F power X. X is considered as 1.6, then what will happen here? WH is proportional to V power 1.6 by F power 1.6, but here F is already there now, so F power 0.6. Okay, or F power minus 0.6. In the same way, eddy current losses. If the V by F is not constant, V square by F square cancelled out. So WE is proportional to V square. Okay, proportional to V square. So W is E is equal to BV square. Here WH is equal to A V power 1.6 by F power 0.6 or F power minus 0.6 if you take in the numerator. So iron losses is equal to sum of these two. A V power 1.6 by F power 0.6 plus B V square. Okay, that means whenever the V by F is not constant, in this case, eddy current losses may not depend upon the frequency. It depends only on the voltage. We will get the questions on this. All of you note down this one. Very important thing. Coming to the next question, guys. A transformer has full load copper losses of 800 watts and core losses are 600 watts and total loss at no load. At no load, what about the copper losses? Whenever the load current is 0, I square R losses are 0. So only core losses. I mean iron losses. Okay. So then total losses are nothing but copper loss plus iron loss. Copper losses are 0, so iron losses are 600. This value is 0 now. So the answer is 600. Okay. So if it is a load or no load, whatever it may be, core losses are always present. Only copper losses are dependent upon the load current. A transformer has hysteresis losses of 30 watts at 240 volts 60 Hz supply. The hysteresis loss at 200 volt 50 Hz supply. Here voltage changes, frequency both are changes. So then how to solve this type of question? These are very repeated question and very easy question. First of all, we have to check the condition. B max is constant or not. Then according to that, we have to apply the proportionality with respect to frequency or voltage, whatever it may be. Okay. So first of all, we have to check V by F is constant or not. V by F ratio, that is V1 by F1 is equal to V2 by F2, then it is a constant. So 240 by 60 is equal to 200 by 50. So that means you will get 4 here, here also 4. So B max is constant. V by F is equal to constant means, students, here just to understand, I am giving all these steps. In the examination, no need to write all these. Okay. So V max is constant, then what is the formula for WH is equal to AF now, or WH is proportional to frequency. As frequency increases, hysteresis loss increases. Frequency decrease, hysteresis loss will be decrease. Here, frequency 60 to 50, that is frequency decreases, means hysteresis losses also decreases. So less than 30, only one option, directly you can use the answer 25. Okay, so whenever you see this type of question, here 240 by 2, 240 by 64, 200 by 54. So B max is constant. So hysteresis loss proportional to frequency. Frequency decreases. So hysteresis loss will be also decreases. 30 less than 30. So the answer is 25. Okay. Losses will be 25. If you want, you can calculate. WH2 by WH1 is equal to F2 by F1. So calculate WH1 30 into F2 50 by F1 60. So 25 you are getting now, but no need to do all this. Okay, all of you clear? Coming to the next one. A transformer having 200 volt to 100 volt, 50 Hz is to be excited at 40 Hz from 100 volt side. From the exciting current to be same, the applied voltage should be dash. Here, what is the meaning of exciting current is same? Exciting current or magnetizing current. You can also say magnetizing current. That is nothing but I mu. So whenever the I mu is same, B max is same. B max is same. B max is same means V by F ratio is same. So V2 by F2 is equal to V1 by F1. Or V1 by F1 is equal to V2 by F2. So we want to find out V2, that is equal to V1 into. So here it is excited which side? 100 volt side. So 100 volt is the V1. Don't confuse here. Exciting it 100 volt side means we have to take V1 as 100 volt side. If they are exciting 200 volt side means we have to take 200 volts. Okay. So 100 volt into V2 by F2. F2 comes to here. F2 is nothing but 40 Hz by F1 50 Hz. V1's, that is 80 volts. So the answer is option C. Okay. No need to write all this. A simple thing. Here they have given 100 volt side you have excited, and at that corresponding frequency is 50 Hz. Now it is excited at 40 Hz. Then what will happen to the voltage if you want to make same exciting current? So as V by F is constant, why? Because exciting current is same means V by F is constant. Here if you want to make V by F as constant, frequency here decreases means voltage also has to be decreased. Then only you will get a constant. So voltage has to be decreases from 100 volt. Okay, so less than 100 volt, only one option, 80 volts directly you can use answer. Or 50 to 40 means here 100 to 80. Okay, coming to the next question. Hysteresis loss are present in iron core coil when dash. In iron core coil when dash. I have already explained this one. Whenever the supply is alternating quantity, then only it is a magnetizing, it is a demagnetizing. Due to reversal of this magnetization, demagnetization, we are getting the losses. Those are nothing but hysteresis loss. So the current is in alternating nature. It is alternating nature. It may be a sinusoidal or may not be sinusoidal. Okay. So if it has positive or negative off cycles repeatedly, that is alternating, guys. So many students having the confusion, alternating, sinusoidal. Okay. So whenever we have positive or negative cycle, that is alternating. Alternating, that is one positive, one is negative, like that. So it may be a ramp, it may be a triangle, it may be a square, whatever it may be. All those are alternating if those having positive or negative. Okay. So sinusoidal is one of them. On which of the following factors does hysteresis losses depend on? I have already given the formula. Hysteresis losses zeta B max power x or 1.6 F into V value. Okay. So it depends upon flux density. Yes. Depends upon frequency. Yes. Hysteresis losses may not depend upon the lamination and time. Okay. So 1 and 2. 1 and 2 means option C. 1 and 2 means options. Okay. Coming to the next question, guys. If the iron core of a transformer is replaced by an iron core, I have already explained this one in this session starting. Then hysteresis losses in the transformer will be dash. Whenever we have the magnetic type of the cores, we are getting the hysteresis losses. If you are using air core, we are getting a linear characteristics. So that means linear characteristics means the hysteresis losses are nothing but 0, almost 0. So becomes 0. Okay, coming to the next one. What is the core loss in a high frequency ferrite core of transformer used in SMPS power supply? Generally, the core losses are 4 to 5%. If you are using ferrite type of the core, that core losses will be very less than 2% or approximately 1 to 2%. So that is 1% given. So we have to give the answer as 1%. Okay, we have to give the answer as 1%. Okay, students, we will discuss the remaining questions in the next session. If you have not subscribed the channel, please click on subscribe button, and also please encourage me with your likes, comments, and shares. Okay, thank you so much, guys. And one more thing, here you are getting the topic wise MCQs now. This will be very useful. And in our channel, you will always get a very good content. Okay, so that is for sure. Thank you, guys.